Okay, this is 4.1 in elementary algebra, and new chapter, new ideas, new things going on here. What we've done at this point is we have learned how to graph linear equations. Sorry that my writing is so bad. Alright, graphing linear equations. And we did that by taking a linear equation like that, took the y-intercept and graphed it, so where it crossed the y-axis, put a point there, and then we looked at our slope as 2 over 1, and from that point we would go up 2 and over 1 for our second point, and we get that there. Okay? And there's our graph. Alright, so one of the things that we've discovered is that any point along this line, if we put it in this equation, if we put the x value in here and the y value in here, this will always make a true statement. Okay? So for example, let's say that we took this point right here, and that point is 0, 1. Okay? And let's put it into our original equation. Y equals 2x plus 1. Alright, so we're going to put 1 in. And 2 times 0, because I took this here, plus 1. 2 times 0, 0. 1 equals 1. And that is a point that's on our line, so it's a true statement. And that's one of the things that I want you to get down as far as doing this kind of math, is that when you solve for x and y, those 2 points will be on the line of that equation. The line that we get when we graph something, whether it's here or here or here or wherever it is, the line of that equation, every point on that line makes that equation a true statement. That's what the line means. All the points on that line make the equation a true statement. Alright, so what we're going to do today is look at linear systems. So this would be a linear system is 2 or more equations. Alright? So let's say, for example, our linear system we're looking at is 2x minus y equals 1 and 3x minus 2y equals 6. And sometimes I'll put parentheses on them like that to show that they're together. That is a linear system. Okay? And what that means is we are going to graph both of these equations. Now remember, we're doing linear equations. So both of those equations, when we draw them, we're going to get a straight line. So 2 equations, we're going to have 2 straight lines. Okay, so let's look at what our options are with those 2 lines. One of the options is that we're going to have 2 lines that cross each other, and they will cross each other at most 1 point. Okay, they'll only cross there. They're not going to go like this and cross several times. They're only going to cross at one place. Okay, if they don't cross at one place, they might never cross at all. They might be parallel to each other. And the other option is they might be the same equation and lie on top of each other. So one line lies on top of the other. They're the same line, basically, because the equation is the same equation. So those are our 3 options. Cross at one point, don't cross at all, or cross on all points, like the one I have there, because they're laying on top of each other. Okay. So one of the things that's important, and pretty much the main thing we're going to look at here, is where these lines cross, the 1 point that they cross. Because what do you know about this point right there where they cross? That point is the point that both equations, this one and this one, that's the point that both equations have in common. They share that point. Okay, and that's what we're looking at, is what point do these lines of 2 equations share with one another? And that's what we're going to figure out. So let's look at example 1 and get moving on that. So hopefully I made it so you kind of understand what we're trying to do here. I don't want you to just do it. I want you to at least know kind of not only the process, but why you're doing it, what it's telling you. All right, so they give me two equations. X plus y equals 3. 3x plus 4y equals 2. Determine whether each ordered pair is a solution to the following system. And what they do is they give you an ordered pair. They say, okay, ordered pair A, -2, 5. And what they're asking for is that a solution to this system. How do you determine that? Well, you put 2 and 5 in the first equation and see if that's a true statement. You put -2 and 5 in this equation, see if it's a true statement. If it's a true statement for both of them, then it is a solution to the entire system. It has to be true to both of them. So let's look at the first one. X plus y, -2 plus 5 equals 3. Is that a true statement? Does 3 equal 3? -2 plus 5 is 3? Yes, it is. All right, let's look at the bottom one. 3 times -2 plus 4 times y, which is 5, equals 2. -6 plus 20 equals 2. That's 14. Does that equal 2? No, it does not. So that means this is not a solution to the problem. All right, it gives us a couple other points here. So instead of A, let's get rid of our A here, it gives us a B. Okay, so B, does 10, -7 make both of those true? Well, let's look. 10 in for x plus a -7 in for y equals 3. So 10 minus 7 is 3. Does that equal 3? Yes. All right, let's try it in this equation. 3 times 10. Okay, equals 2. So 30 plus -28 equal 2. Yes, it does. 30 plus -28 is 2. So that means these 2 points are where the graph of this line and the graph of this line cross. Okay? 10, -7 is where those 2 lines cross. And there's only one place where those 2 lines cross, at 10, -7. They don't cross anywhere else. Okay? So, that makes 10, -7 an answer to the system that we just drew up there. And this is the system right there, those 2 equations. All right, so let's look at example 2. And it wants us to solve a system of equations by graphing. So let me get a graph here. Okay, so there's example 2. We're going to graph those 2 equations. And so let's look at this one first. And what we're going to do here is we're going to make a table. I mean, you can do it lots of different ways, but the table for something like this without a bunch of numbers is pretty easy. So 0 for x. So if I put a 0 in here for x, what does my y have to be? My y has to be a 4. 0 plus 4 equals 4. What if I put a 2 in here for x? 2 plus what equals 4? 2 plus 2. What if I put a 4 there? 4 in for my x. 4 plus what is 4? 4 plus 0. All right, so let's graph this. 0, 4, 2, 2, 4, 0. Okay, so there's the graph of my top equation. Let's do the bottom equation in red. So again, let's put on a graph, and let's say we put in 0 for my x. 0 minus some number equals -2. So it would be 0 minus 2, right? 0 minus 2 is -2. What if I put 4 in here? So 4 minus something equals -2. So 4 minus 6. So 4 minus 6. Alright, so let's graph that. 0, 2. And 4, 1, 2, 3, 4, 5, 6. Okay, where these two lines cross is the answer. Okay, when you're given two equations where they cross, that's what they have in common with each other. That's the answer. So for this one, it's kind of a guess. You're not really exactly sure because my lines aren't perfectly straight, but it looks like it's around 1, 3. So I'm going to put that down as my answer. My answer is going to be the point 1, 3. Now, if that is the answer, when I put it in this equation and this equation, it's going to be a true statement. So let's try that top equation. 1 in for x, 3 in for y equals 4. That's a true statement. 1 in for x, 3 in for y equals negative 2. 1 minus 3 is, in fact, negative 2. So that proves that that point is the answer to this problem. Okay, so that's how you show how you solve a system by graphing. All right, so let's look at example 3 at another one of solving a system by graphing. And we'll see if I can do that on this one video here. We've got x plus 2y equals 8. And 2x minus 3y equals 2. All right, so what we're going to do here is we are going to put this in y equals mx plus b format. So let's take this top one and rewrite it here. X plus 2y equals 8. Move that x over. So I have 2y equals negative x plus 8. Divide by 2, divide by 2. And I get y equals, split these up, 8 over 2 is 4. Okay, so notice I have this. That's kind of a weird looking thing. So let's rewrite it as, I'm going to put a 1 in front of the x, which I can do that. Okay, so there is my equation in slope-intercept form. Alright, so I cross at y is 4, and my y over x is negative 1 over 2. So I go down 1 over 2. So there's that line. Okay, so let's go ahead and get rid of all this because I don't care about this now. And we're going to do the other equation, the bottom one, the exact same way. We're going to take 2x minus 3y equals 2. Subtract 2x from both sides. Negative 3y equals negative 2x plus 2. Divide by negative 3, divide by negative 3. Gives me y equals, split these up, negative 2 over negative 3x plus 2 over negative 3. And so two negatives give me a positive, and this can just be made into a negative 2/3. So it crosses at negative 2/3, so that's about right there. And the slope is 2/3, so that means I go up 2 and over 3. So somewhere around there, kind of guessing. Okay, and I come up with an equation that looks like that. So this point right here is where my two lines cross, and because my two lines cross there, that's the solution. Now, again, my drawings aren't real pretty, aren't real straight, so you're not going to get an exact solution. But you get somewhere, it looks like 4, 2 is where they cross. So we take 4, 2 and plug it in there, 4, 2 and plug it in there, and lo and behold, we find out that it makes both of those a true statement. So this point right here, what both these lines have in common, is the correct answer. Alright, next video we'll go on to example 4.